Hello, everyone, and welcome to a unique discussion about AI and our society, brought to you today by Microsoft Research. My name is Siddhartha Sen, and I work in the Microsoft Research Lab in New York City, where I try to build AI and hybrid human AI solutions to improve our cloud systems. And this is why I feel especially excited and privileged to have this conversation with leading experts in the field of AI. Joining me is Professor Yoshua Bengio, who is a professor in the Department of Computer Science and Operational Research at the University of Montreal. He is SAFAR's Learning in Machines and Brains Program Co-Director and is also founder and scientific director of MILA, the Montreal Institute for Learning Algorithms, the world's largest university-based research group on deep learning. Among his many honors, Yoshua was a co-recipient of the 2018 ACM L&M Turing Award for his foundational work in deep learning. Welcome, Yoshua.
Hi.
Also joining me is Dr. Chris Bishop, who is a technical fellow and laboratory director of the Microsoft Research Lab in Cambridge, UK. Chris has generated and overseen cutting-edge AI research across a variety of domains, from cloud infrastructure to healthcare. He's also accompanied by a long list of honors: Fellow of the Royal Academy of Engineering, Fellow of the Royal Society of Edinburgh, and Fellow of the Royal Society, to name a few. Welcome, Chris.
Hi, Sid. Thanks for the invitation. Great pleasure to be here.
Thank you both for being here. I wanted to pay some homage to the current environment we are all living in and talk about the role of AI in our health and our environment, both of which are facing unprecedented times, shall we say. So Yoshua, you recently put forth a long paper on how to tackle climate change with AI. Before we get into that, can you tell us a little bit about what inspired you to work in this space?
Well, I feel like as AI is something that's not just happening in the labs, but actually is useful in the world, I have a responsibility to think about where it could be most useful, and in particular where there are the biggest challenges for humanity. I think clearly climate change is one of them. And so many of my colleagues and I have been looking at many different approaches to try to use machine learning to help fight climate change.
Great. So climate change is actually something that's very close to home. I have an atmospheric chemistry and air quality researcher right next door. It's my wife, actually. And in one point she's made when she's talked about this, as she's gotten more and more interested in ML, that she feels like some of the problems that could most readily use ML don't seem that exciting, perhaps, to ML researchers. So let me start by asking you, is there a problem in climate change that excites you as an AI researcher?
I'm interested in a number of these problems. So the biggest project I've been involved with right now is one that has nothing to do with climate modeling, but more like the psychological aspects of things. So we've been using generative models to produce images that would help people feel in their guts what it might mean in the future as we have more events like floods and fires and droughts and so on. And so we've used these GANs, which actually came out of my group many years ago, and thousands of people have been working on in the last few years, to generate transformed images of, say, your house under these climate situations, so that people can get a sense of, not just the numbers, the projections, but also what it might mean for them in a way that's emotionally stronger. Yes. Well, I mean, it's fast forward in quotes, right? Because nobody has a crystal ball, and the climate models are not good enough to tell us all the answers we would like. But we can, take data of how houses look like when they're flooded, and then turn a picture of your house into a flooded house, for example.
That's really cool. So that'll really hit home.
Yes, exactly. Another project that I find really exciting is in the development of new materials for fighting climate change. So that's either on the side of batteries or carbon capture. So there's a nice connection actually between this work and the work on the healthcare side of designing new drugs. In both cases, machine learning can be used to search in the space of molecules for different purposes. They can be used to predict, what would be the properties of a given material if you give the chemical formula to the system. But then you can turn this around and build search or generative models that look for molecules that have the desired properties.
Great. So one thing that some of the examples you bring up is making me realize is that having this very large search space seems like a challenge, and climate also presents some other challenges. For example, things in the short term for climate models are seem to be very chaotic, whereas the longer term trends seem to be slower and more predictable. So how do you think AI can help climate modeling given these kinds of challenges?
Yeah, so I actually have also a student working on climate modeling, and our idea is, well, so first of all, there's already some work in taking physical models that can be very slow to simulate and then train, say, neural nets to predict how things would unfold, but faster than the physical model. And especially when you get to high spatial and temporal resolution, this becomes a big problem with current physical models. So the good news is we can train machine learning systems to imitate these physical models, but do it faster. So that's one kind of already established method. You can use them to generate, potential futures. So these don't have to be deterministic. They can be stochastic models of the future. Now, the thing that I'm really excited about is to think about how deep learning specifically can help by learning better representations, better abstractions. So, what is it that physicists have done or climate scientists have done in the last 100 years or a few hundred years is come up with good high-level abstractions, like what statistical physics allow us to talk about things like temperature and humidity, but really these are not properties of individual atoms. They're like abstract aggregate quantities that allow to run simulations of what could happen without having to go at the level of individual atoms. So the question is, can we use machine learning to discover new, potentially useful abstractions that allow to simulate things about the future, potentially at long time scales as well as short time scales, that currently we don't know how to do.
I see. So you're saying that in some ways, by using deep learning, we might be able to, new abstractions might emerge that we never really thought of as
Yes.
humans sitting and thinking about this problem just by kind of studying how these deep networks are evolving.
Well, they would be trained with the objective of discovering the abstractions that have the property that if you simulate with that level of representation, you're able to mimic what the physical model would do, except you would do it with much lower spatial and temporal resolution.
That's very cool. Okay, so when thinking about these kinds of critical decisions about the environment, I'm just really glad that someone like you is passionate about it and looking towards it. Another area that also seems to have an outsized impact on human society and life is the medical field and health. And I know, Chris, that you and the MSR Cambridge lab have been working on this space for some time now. Can you tell us what motivated you personally to think about AI's role in health?
Yes, sure. So I've been in the field of machine learning for something like 35 years, I calculated. I missed the very first NeurIPS conference, but I think I've been to most of them since then. So I've been around a while. And I've always believed that applications in the area of healthcare represent one of the most exciting and one of the most potentially impactful domains for the application of machine learning and artificial intelligence. I've always been fascinated. When I was a research professor before I joined Microsoft in my research group, I worked with, it was based in Birmingham, and I worked with clinicians at the local hospitals on a variety of different projects. And when I moved to Microsoft and helped set up the MSR Cambridge lab in the UK, from the very earliest days, we've always had a number of projects in the healthcare domain. But healthcare has not been a really big thing for Microsoft for many of those years. So, I really just using the freedom that we have in Microsoft Research to pursue our interests, to pursue healthcare. But really, in the last few years, Microsoft has become very much more interested in the healthcare domain. And it's sort of given me license as lab director to really expand our investments in this area. So I've been really pleased. We've been able to take on a whole range of different topics, probably far more projects than I have time to describe today. But I'd be more than happy to pick out a few highlights and tell you a bit about them.
Great. So I guess one nice thing about that flexibility is that you've been able to kind of direct the lab towards this exciting space and this very valuable space, I think. One thing I think that the pandemic has showed us is how stressed our medical systems and workers can become, when an illness spreads and when there's more pressure on our hospital systems. Do you think that AI can play a role in reducing the stress or improving the efficiency of our medical systems? And if there's an example of a project that your lab or you have been working on, please feel free to tell us about it.
Yeah, sure. So, first of all, I think one of the big challenges we face as a society is actually just the increasing cost of healthcare. In Western nations, it represents a substantial and ever increasing proportion of GDP, and that trend is set to continue. We're all living longer thanks to benefits of healthcare. And so we're suffering from more of these chronic diseases like dementia. We're learning to not cure cancer, at least we're learning to live with cancer rather than die with cancer. So again, people living for longer periods of time, living with these diseases, and just the financial burden, societal burden of these diseases is just increasing. And so there's as you say, tremendous pressure, not just the local pressures, the immediate ones from COVID-19, but sort of more systematically, we're seeing healthcare systems just creaking under the strain, the pressure of the ever increasing demand. And this is one of the reasons why I think a data-driven approach using machine learning can really be helpful, because it can help us to automate and help improve efficiencies and really allow our overstretched frontline health workers to spend more of their time focusing on things which really resonate with their skills and their passions, and less time doing more of the sort of the routine, the mundane things which actually machines are rather better at. So yes, I do think machine learning has a tremendous role to play in healthcare. It's also a very challenging space, though. There are lots of challenges to do with the way healthcare systems are structured. It's very different in the US from the UK, for example, so the challenges are different, but they're there. And of course, and probably we'll talk a bit about this later, but we also have to think about the fact that these techniques are data-driven. Data is really at the core of this. And so the data in this case is very often personal healthcare data. That's extremely private. It can be very sensitive. And yet we know machine learning works best when we aggregate data from large numbers of sources and use data at scale. And so there's an intrinsic tension there that needs some very, very careful thought and very careful management.
So an example of something I think you've spoken about in the past has been this idea of doing kind of tomography on tumors and the kind of tedious work that entails. And I guess that's an example of something where you feel like AI can come in and remove this task and save time from people who are manually looking at all these 2D images, and maybe give that time back to spending time with the patients.
Actually, that's a great example. Yes, we have a project called Inner Eye. I mean, it really has its origins about 10 years ago. In the last few years, we've really been increasing the scale of collaborations. We have a number of collaborations around the world associated with the Inner Eye project. One of the longest standing is with our local hospital, Addenbrooke's. It's one of the largest teaching and research hospitals in Europe, and we collaborate with their oncology department there. And really, so technically, first of all, what we're doing is we're using convolutional neural networks and attention mechanisms and so on to do segmentation, to take a three-dimensional scan, might be a CAT scan or an MRI scan, identify organs, vital organs, but also identify tumours, and in particular to segment the tumour, to find the boundary of the tumour in 3 dimensions. This has various applications. I mean, in clinical trials, you want to monitor quantitatively the response of the tumour size to treatments and so on. But the big application is in so-called radiation therapy planning. So sadly, about half of us at some point will have cancer of some kind. About half of those people will end up having some form of radiation treatment. So this is a very, very widely used technique. And it involves firing in radiation in quite a sophisticated way in 3 dimensions, with the goal of having as much radiation hit the tumour and damage the tumour as possible, while protecting good tissue and especially protecting vital organs, the brain, eyes, and so on. And so it's very important to have an accurate 3-dimensional map of the tumour. Now, the way that's done today is that a radiation oncologist will sit down in front of a workstation and will take that 3-dimensional scan, and they'll go through 2D slice by slice with a stylus, and then they'll manually mark out the boundary of the tumour. Now, even for a simple tumour, that can take 10 or 20 minutes. But if the tumour is metastasized, it's not just a single region, it's many, many regions. It can take sometimes many hours. Now, of course, this is a great example of where machine learning can provide some automation. It can be trained on pre-segmented tumour images, and it can learn to find those boundaries. And so the workflow in practice, in real clinical practice, in the research environment of Addenbrooke's Hospital, we've seen something like a 90% improvement in the time it takes to do these segmentations. And what's really interesting is that it's not just a black box automated process. It really is the radiation oncologist, the human expert, working in close partnership with the machine learning. The machine learning produces a sort of candidate segmentation, and the oncologist then goes through and effectively verifies it, but also has the chance to make any little tweaks. If there's a region they're not quite sure about, they can perhaps include that in the definition of the tumour so that it will also be treated under radiation therapy. And so it's just a really nice example of having the machine do the part that's frankly very, very tedious and not really utilising the expertise of that highly trained individual, and instead allowing them to focus on things like engaging with the patient, doing the overall process planning as part of a tumour board, what kind of treatment should this patient have and when and so on. So it's a really nice example of cost savings and also this synergy between machine learning and humans.
So you've touched on some interesting issues with respect to how machine learning and humans interplay, and let me try to tackle two of them that stood out in my mind. So Yoshua mentioned this aspect of personalizing climate change for people and making that something that's a reality for them. Personalization seems to be something that machine learning and AI are good at and that they can do at scale. Do you see the same kind of personalization happening in medicine in the future of AI in health?
Yeah, let me answer the question by sort of popping up to 500,000 feet and then I'll dive back down to healthcare again. There's clearly something very exciting happening in the world of AI right now. There's a lot of talk about the AI revolution. There's clearly huge investment, tremendous interest, many applications and so on. And when I think of how we characterize what's really going on, the way I think about this, and perhaps this is something of a Microsoft perspective, but it's really a revolution in the way we create software and therefore the way we create technology. So one way to think about this is to say that, well, for the last 40 years, we've programmed computers, and for the next 40 years, we're going to train computers. And we're going to train them using data and using machine learning algorithms. And so that's very fundamental. If you think about the old way of producing software, where you build a piece of software, it's very expensive, you need lots of very smart developers working really hard to create that software, and then you can replicate it essentially for free, give it to hundreds of millions of people. And so although it costs a great deal of money to produce the software, the cost per person is very low, and so very sophisticated software becomes affordable to hundreds of millions of people. The downside, though, it's one size fits all. I mean, you might customize it French, English, German or something, but essentially it's one size fits all because you can't afford as a private individual to have an army of developers produce a piece of software just for you. But one of the promises of machine learning is this idea of personalization, the idea that actually, yes, you may train a big natural language model with huge compute and huge amounts of data to produce some generic model, but then it can be fine-tuned to you as an individual, to your particular characteristic, style, whatever it might be, using relatively small amounts of data and relatively small amounts of compute. And it's not just personalization to individuals, it might be personalization to a particular city and how the characteristics of that city differ from another city, or it might be an aircraft engine which has its own particular vibration characteristics and so on. So that idea of personalization at scale, the idea that you can provide technology to 100 million people and they each get something that's different and that's tuned to them, that becomes possible in this new world of using machine learning to create technology. So that 500,000 foot view, for me, personalization is one of the big benefits of moving to this data-centric way of creating technology. In terms of healthcare, for sure, I mean, we have a lot of variation as human beings, much more than, say, aircraft engines coming off an assembly line. And not only genetic variation, environmental variation, but things like comorbidities, for example, if you think about clinical trials. So you have this very, very controlled environment involving small numbers of people where you try to assess whether a drug or a placebo gives a statistically significantly different effect. It's very expensive and it's very focused and narrow and somewhat artificial, because in reality people will have comorbidities, and now you have a combinatoric possibilities of the different comorbidities that really make us very unique as individuals. And so again, healthcare, perhaps as much as any domain, is one in which this new way of creating solutions that allows for personalization could be particularly powerful. That said, I think there's a tremendous amount we could do in healthcare with just, good old-fashioned logistic regression and some good sensible data and just getting it out there in the field and using it. So as machine learning people, we love to think about the challenges of machine learning, the frontiers of the algorithms and so on. But actually, I think there's even a tremendous amount we could do in the very near future if we have the will and the determination, that can impact healthcare in really exciting ways, even just with the sort of algorithm and technologies that we already have.
So Yoshua, I know you mentioned personalization earlier in climate change. Do you have any other thoughts about personalization and its role, and whether what Chris was saying about just the simpler stuff making its way in first being already impactful?
Yeah, sure. Of course, you always want to start with the simple stuff and make sure you don't overkill. I want to add a few things. So one on personalization, there's a lot of exciting things happening in biology and the tools that we have to monitor what is going on in cells, which can really help us a lot to personalize treatments. So it's not just the personal health records that can be used as input. It's also, now exactly what is going on in some of your cells that you're trying to treat. And that could be measured at a resolution that was not even conceivable a few years ago. Looking, for example, at expression data, where all of your 20,000 genes, how much are they expressed in proteins, and that changes a lot from person to person, or even from one time of your life to another time of your life, and that can really give us a glimpse into what is going on inside the cell. So I'd like to connect that with, I think, the potential for machine learning, not just to help us to design treatments in the short term, but also in the longer term by helping us understand biology. Because the sad truth is that we don't understand how human cells work. We barely understand how simple bacteria work. If you think of cells as very complicated machines, really there's so much that we don't understand in human cells, or even mammal cells, or bird cells. And it's really important to understand that because, for example, in the case of cancer, it's really the causal structure of all these interactions between the different types of molecules that are swimming in your cells that matter to find the right treatment. And it might be, again, coming back to personalization, that for a particular person with a particular cancer, so cancer is not the same for everyone. It's coming out of mutation. So and even in a particular person, at some point in the course of the disease, there's a treatment might be appropriate, and later it might be a different treatment, a different set of drugs, because we're going to really try to find the particular um, kind of mutated cells that are currently causing trouble. So personalization, I think, for things like cancer and many other diseases is super important. And one of the things that I think where machine learning can help us, in addition to understanding the causal structure of what's inside the cell, which is more like basic biological science, machine learning is making progress in incorporating causality into the models. And the other place, which I had already mentioned for climate change, is machine learning used for searching in very high dimensional spaces. So for example, in drug discovery, we've been working on building new antiviral treatments for COVID-19, either by combining existing drugs, and then you have 2 or 3 drugs out of 10,000. That's too many to try, right? And so you need to have tools that are going to guess good candidates, and then you're going to use biological assays to find the ones that are most promising, and then you're going to feed that back to the machine learning in order to improve the model. And then you can use really cool advances in reinforcement learning, in what's called active learning, to really create a whole cycle of interaction. So between the learner, which tries to figure out what would work to solve the problem, and the real experiments in biology or chemistry, where you only have a limited budget of things you can try. So it's really at the frontier of what we're able to do now. And coming back to one of your earlier questions about challenges for motivating machine learning researchers to work on these AI for social good problems like climate change or some healthcare problems. Well, it turns out that on some of these problems, we are really touching the frontier of how we can solve problems with machine learning. So causality, the interactive aspect of learning in an environment that changes, where the learner can query, when the learner can change the environment, that is something, of course, that's more connected to reinforcement learning, but that we don't master, by far. So that can be both exciting for PhD students who want to contribute to machine learning and really have an impact on society.
Okay, Joshua, thanks for that. It's kind of fascinating to think about just how much we have to understand about the cell structures of people, and I think you're right that can be a great motivating factor for researchers on both sides of the equation. And I also like your point about how it takes time to try out some of these new combinations of things that you're exploring in real life, and so the machine learning and AI has to be intelligent about the suggestions that it makes for things to try out. Chris, you mentioned that you might have an example of personalization in medicine and healthcare that you wanted to tell us about. I'd love to hear about that.
Yeah, sure. It is an unusual example. I think it's become quite an important one. So about a year ago, we set up a new collaboration, a partnership with a company based in Dublin called Silver Cloud, and they specialize in development of an app to assist with the treatment of mental health, in particular low and moderate levels of anxiety and depression. This is not an app that you just download from an app store. This is something that's actually prescribed by medical professionals like the NHS. And it really acts as an interface between the patient and helpers, professional helpers who can provide what's called cognitive behavioral therapy to help with these mental illnesses. And so it's not AI that's directly trying to provide therapy, but what it does do is provide something that's accessible to the user 24/7. And of course, in the process of acting as an interface between the patient and the helper, the therapist, necessarily a lot of data is flowing, which has the potential to be used to improve the quality of the service that's provided and the effectiveness of the therapy. And so for about the last year, we've been working with them on what is still obviously at a research stage, but a project that's trying to understand how we can use machine learning techniques in relation to that data to see how to better target the therapy, better improve the personalization of the therapy to the particular individual, and not just to the individual, but also how things evolve over time, how they respond, how external factors in their lives cause their levels of depression to rise and fall, perhaps, and we need to moderate the levels of therapy and response and so on. So it's a rather different kind of healthcare application, but one, of course, that's become incredibly important since lockdown and with the economic impact of COVID-19. In some cases, we've seen a doubling of the number of referrals of people to mental health services. And so anything we can do to assist those mental health professionals through the use of this data-driven technology has got to be welcome. So it's, again, another example, but I think a very different but very relevant example of the use of machine learning for personalization.
Yeah, I think that's really interesting. I think we sometimes we focus on things like drug discovery and other, more concrete uses or applications of AI, and we often forget about things like mental health and that kind of human connection. So I actually really like the points that both of you have raised about how AI and humans are going to interface through these applications, in the environment and in healthcare. In a lot of cases, it seems like it's not a very clear-cut situation of AI coming in and dominating a human solution. Sometimes AI seems to play the role of an assistant, as you were describing, or a more synergistic role. So I guess one question I have is, what do you think the fundamental issues are, or that may arise as AI becomes more powerful, initially in some of these narrower domains, but potentially stronger than humans in some of these tasks? Joshua, do you want to answer that one?
Sure. So I think that there's interesting things to think about on both sides of this question I can think of. So one is on the technological side, things like AI safety and like how do we make sure that AI system is going to be more robust, is going to be more attuned to the needs of humans and potential harm that they could cause to humans or to society. And then on the other hand, we have the question of how should society adapt to the presence of these powerful tools to make sure that they are used in ways that are aligned with public good. and both are challenging, right? So, but what's interesting as I think about both of these is there are commonalities in a way that between those two questions, right? So of course, in one case, we want to govern how machines work so that they serve us in a useful and positive way. And in the other side, what we're trying to govern are human beings and corporations and countries, which who take decisions that could be harmful to the rest of society. And as technology becomes more powerful, this becomes a more pressing question. And many people around the planet are, wondering how we should, what kind of principles we should lay down to help us maybe change the rules of the game in one form or another in order to deal with this power that we have unleashed in the world. So we want to make sure that it's used for good. And for that part, I think what governments need to do is think more about the kinds of incentives that could help the development of really beneficial applications of AI. Let me give you an example that I'm currently thinking about. There's a problem right now where pharmaceutical companies are not looking for new antibiotics. And if we don't find new antibiotics quickly, in the next couple of decades, there's going to be eventually tens of millions of deaths per year. That's much more than COVID-19. And so we have a problem. Like really, the current rules of the game are not pushing the actors in the direction that is needed. Just like for climate change, we need to change the rules of the game so that individuals and corporations somehow change their behaviors so that globally we all in a better shape. So the interesting thing is the problem of mechanism design, or how do we change the rules of the game so that whether an AI or a corporation or a country behaves in a way that is better for the common good is something where machine learning actually has interesting things to say. And of course, it ties in with questions of safety and also really interesting questions of uncertainty that were raised, for example, by Stuart Russell. In other words, it's not just about predicting what may happen as a consequence of our actions, but taking into account the fact that we don't know. For example, the AI may have some uncertainty about whether some action may cause harm, in which case you don't want to take that action. Similarly, if there's uncertainty about climate change, well, you want to be on the prudent side and you don't want to pollute and risk the lives of many people and species.
So this kind of putting AI in the context of human society is something that Chris, you also mentioned that you think a lot about, and I see what you're saying, Yoshua, about this. You're training AI models, but you're also training society in a way to work together. It seems like a combined and a dual effort. So I guess, Chris, in this context that you mentioned about how you have to really think about AI being being put in the human context, how do you think about safety and some of the privacy issues that you mentioned and alluded to in some of the work you've been doing?
Yeah, that's great. It's a great question. I think as we talk about AI becoming more powerful, well, first of all, of course, it is a powerful and general technology, and such technologies often bring potential hazards and potential risks, and it's very important to be on the front foot and recognise those and try and stay ahead of the game. I think it's not the increasing power of the algorithms as such that presents increasing levels of risk. I think it's a little bit more indirect. I think as the algorithms become more powerful and more capable, they become much more widely used because they generate utility in so many different domains. And it's just the existence of algorithms that are data-driven versus ones that are handcrafted that introduces new kinds of risks and new kinds of concerns around bias and fairness and access and ethics and so on. I think one thing that I feel very very passionately about in this space is to do with public engagement. If I think about, I think I'll take a couple of sort of European examples that I'm more familiar with, one of which worked out very badly and one of which worked out very well. And the difference between them is very clear. The one that didn't work out well was genetically modified organisms, which is a technology that can bring many benefits, but naturally raises some concerns and various issues. And is important that we have the debate. That debate, unfortunately, didn't happen. And it's partly down, as much as anything, to the scientific community. We didn't engage in a public way early enough. And so it was driven by headlines in newspapers and so on. And the end result was a technology that could have been very beneficial was sort of shut down for several decades in Europe. I can contrast that with human embryology and fertilization, which is an area which, again, many potential benefits, but clearly lots of ethical concerns, where I think in the UK we did a fantastic job of getting on the front foot, first of all through setting up all the right governance processes, ethics committees, boards of approval and so on, but also, perhaps even more importantly, engaging with the public in a very proactive way so that everybody could understand the benefits and could see this at a very human level. So it's not just an abstract thing. Instead, one professor was giving doing television programs where you'd get to meet a couple that were trying to have a baby and they couldn't get pregnant, and here's some in vitro fertilization technology could help them and so on. It really told the human story and talked about the benefits of this rather than it being very abstract or a scientist just saying we know better, trust us, and that it doesn't land well. So I think here we're doing a good job, and I think we could do an even better job of having a very informed public debate where, because it'll affect everybody in society, and so everybody needs to have a voice. And I think that early and proactive public engagement will do a long way to helping us mitigate the risks, avoid the pitfalls, but also really deliver the tremendous benefit that this technology can bring. Because you could argue that even with the healthcare data that's already collected, if we don't use that data, never mind data we could potentially collect in the future, if we keep it locked up and we don't use it to save lives, and we're confident it can save lives, that itself is an ethical concern. Not using technology that can be beneficial is itself an ethical problem. So I think being on the front foot of that debate and having that debate in an open, transparent and public way is really super important.
So it seems like being able to use AI effectively in this way and thinking about safety, it's a combined effort between how you design these AI systems and also the societal structure around their use. Is this something that you look at AI researchers as having the responsibility to make sure things work out in the way that you described in the second example? Or do we need, a combination of people from different disciplines to work together to make this, to deliver these AI solutions in a way that is not only safe for the humans and for society, but also something that we kind of embrace and we reap the benefits of?
Yeah, that's a great question. So, I've been in this field for 3.5 decades, and for the first sort of 2.5 decades, there was really only one thing that we had to do, which was reduce the error rate, because the algorithms really just didn't work, apart from some niche applications. They just didn't work well enough to be ready for prime time for the real world. And so we had a very focused community of machine learning researchers really working together and even competing with each other as well to sort of try to get the error rate down and try to get closer to the point where these things could become useful. And that's all that really mattered, is all anybody really cared about. Then, of course, sort of a decade ago, we had the start of the deep learning revolution, and with some real breakthroughs in the capabilities of machine learning, particularly neural networks. And suddenly we had technologies whose performance was extremely good and with many, many potential applications. And at that point, I think the research horizon expanded enormously. At the heart of it, you still have a machine learning algorithm, a neural network, and you have data and so on. But there is a whole penumbra of new issues that arise when you go from the laboratory to the real world. I mean, for example, security. Nobody was going to attack my latest NeurIPS paper, but when you make an online service with 100 million people, there are all sorts of actors in the world of various kinds who, for various reasons, will try to attack it and disrupt it. And you have to deal with adversarial situations. We've already talked about the ethics of deploying technologies, fairness, accountability, biases that creep in. If you learn from data and the data is biased, you can inherit those biases and even amplify them. And conversely, perhaps technology can help reduce bias. So in terms of the field, it's become highly multidisciplinary. In fact, even in our research lab in MSR Cambridge, we've actually reorganized the lab. I mean, a decade ago, we were organized like like a university into departments. We had a sort of machine learning department where the machine learning researchers have their own floor, their own budget, their own meetings, and so on, and not really have much to do with all the other disciplines. Today, we organize around projects, and they're very multidisciplinary. We bring machine learning researchers together with engineers who know how to build robust software good for the real world, with designers who know how to make this actually work in the real world, people who are experts at human-computer interaction, so that it's usable and user-friendly and intuitive and easy to understand, security experts, and so on and so on. It's a very, very multidisciplinary world now, because we actually want to deploy things in the world to do societal good and avoid the various pitfalls that we talked about earlier.
Yeah, it seems like a lot to, I mean, I've always felt like it's a lot to ask of, an AI researcher to do the research, to not only do that, to mentor students, manage projects, think about how society will react to their work, handle policy. I mean, there's just so much we're asking of research scientists these days, because their work is put into larger context. Yoshua, what do you think about that kind of interdisciplinary effort that is needed to make a solution like this succeed?
So I believe that we need to do both things. We need our budding researchers to broaden their base of understanding of science in general and how society works. And we need to make sure that they don't just work in their little tiny field of the science, but also become accustomed to working with experts in other fields. And it's one thing to to be strong in your area, but really you have to learn about things like um, ethical concerns. You have to learn about being humble about how much you don't know. That means that you have to collaborate with people who know less about your expertise and know more about some field that, for example, machine learning is going to be applied to. And the other thing I would add is, unfortunately, right now, the culture we have in machine learning is not is not encouraging the grad students to work on these applied fields, which could be multidisciplinary. This is not sufficiently rewarded. It looks like the reviewers, for example, in machine learning conferences are favoring contributions that are really go at the heart of the basic fundamental questions in machine learning, but not so much these multidisciplinary or more applied works. And this is very unfortunate, because we're losing a lot of people who would want to do that, but feel like they're compelled, in order to get the recognition from their peers, to work on the fundamental questions. We do, of course, need to do a lot of fundamental research, and this is something I continue doing very strongly. But we want to change the reward system. So this is something that I think we can do, and I see more and more of that. This is an example, of course, the kind of workshops like the climate change workshop and the AI for social good workshop and the medical applications workshops that are more and more popular in machine learning conferences are a witness that things are changing. But I think we need more, and we need people to have a better global view of how their work fits in society and could have both positive and negative impacts, and they need to be feeling responsible for their role in all this.
Yeah, I actually really look forward to that, because I hope that as that kind of work is encouraged, that kind of multidisciplinary work is encouraged and rewarded, we'll see more and more people come out on the market like that. And I think that'll actually help us hire more diverse teams, which my conversation with you is making me realize that we really need to hire broadly and diversely in order to understand all these dimensions of the problems that you're talking about. So that's something I really look forward to in the future. So I want to close, but I wanted to ask you. I didn't want to ask you to predict the future of AI in your respective fields and areas of focus. I know that's always a tempting question to ask when you have guests such as yourselves. But maybe you can leave us with something that you would personally love to see us achieve as a community, as an AI community, maybe within the next 10 to 15 years. That if you saw that, it would make you just really happy. And feel free to choose something that's really personal to something that you're passionate about. Chris, do you want to start?
Yes, sure. I mean, there are many things in this field that can make me very happy looking forward 10 years. But one thing that I would love to see is something that we call the hospital of the future. And the idea is the hospital may not even be a physical building in quite the same way we think about it, but a hospital in which everything is data driven. Everything really exploits the power of data, whether it's just making sure you order enough syringes all the way through to treating cancer. And the power of that, the potential of that to save lives and to save costs, which is incredibly important as well, improve the lives of patients and of the clinicians and frontline workers providing healthcare. I think the potential of that is enormous. So we think of that actually as a sort of North Star. Our goal is to build the hospital of the future. We also recognize, though, that you can't just sort of do that out of the box, that you have to start with very specific proof points. And in a way, it feels like we're still going up the steep part of the hill. We're building these proof points. We're very excited about projects like Inner Eye, the medical image segmentation project, because we're really seeing just how beneficial that can be in a clinical environment. And my guess is over the next decade, we'll see a real phase change. We'll see more and more of these proof points that demonstrate the credibility and the capability of machine learning in a clinical environment. And coupled with the pressures to deliver healthcare more effectively, we'll see a kind of turning point, and then we'll cross the hill and we'll be motoring down the other side at ever increasing speed as we really embrace the capabilities of these technologies, all the while keeping in mind the ethical and privacy considerations. So that's my hope for the next 10 years.
Great. And Joshua?
Well, I wholeheartedly share Chris's hope, but let me balance his with something that's more on the science of AI. So one of my dreams, which could come through in the next decade, but really could be also 100 years, is that we find principles of learning that, for example, allow a child to actively explore her environment to understand it and build an understanding of it that's profound, that's causal, that allows her to change things to achieve the effects that she wants, but also allows her to just do the right thing, the curiosity, the playfulness to acquire the knowledge she needs to build that understanding of the world. So that's something we're very far from, but I think we're starting to build the conceptual tools towards this kind of capability. And of course, it's hard to say in terms of applications how it could change things, but I'm very sure that there are a lot of places where this sort of ability would change the game completely.
And so do you draw a lot of inspiration from how children interact with the world when you think about AI?
Yes. In fact, it started when I had children. But I continue having an interaction with cognitive scientists, neuroscientists who try to understand child development and what is going on in our brain at different stages of our development. I think this really can provide amazing inspiration, because the current, their current deep learning is only helping us resolve some of the capabilities of humans, and there's like a whole other set of capabilities that for now we have no clue how to deal with.
That's both of these things sound extremely exciting to me. I mean, just getting a bite out of what children can do and doing and understanding that better is exciting. Thinking about the hospital of the future, especially during the current times, is also something that gives me a lot of hope. So Joshua and Chris, I wanted to thank both of you so much for a fun and insightful conversation. I'm really amazed by the work you are doing in healthcare and climate change and all the other domains that you talked about that really affect us as a society. And of course, all the foundational work you did in AI to bring us to this point so that we can do this other work. And for those of you attending NeurIPS next week, you can catch Chris giving the Posner lecture titled The Real AI Revolution on December 9. And Joshua will have a workshop, as he mentioned, on tackling climate change with ML. And as always, you can visit microsoft.com/research to learn more about this and other research going on. So thank you both again for your time.
And thank you for your questions.
Thank you, Sid. It's been great.
So thank you all for joining us today for this fascinating conversation with Yoshua Bengio and Chris Bishop. And there are a whole bunch of questions coming in the live stream that we're trying to monitor and publish. So we won't get to all of these questions today, but I do have with me Chris and Yoshua, who are going to join us for this live Q&A session, where we're going to ask some of the questions that you've asked during the call and some offline before the call. and ask them to our guests. So hello, Chris and Yoshua. Thank you for joining us.
Hello.
Thanks, Sid.
So let's kick this off. So there are a bunch of questions in a variety of areas. Some related to the content of what was spoken during the conversation that we had. Some related to advice about ML. Some related about how ML and society interact. So why don't we start with a question about how to balance the kind of technical and social aspects to handle bias issues in ML. So Chris, do you want to take a stab at answering that question?
Yeah, it's a great question, actually. I think it sort of builds on some comments I made earlier about how, if you look at the history of machine learning for sort of 25 years or so, at least since I joined, the focus was really on the algorithms, the machine learning techniques. And then, starting about 10 years ago with the deep learning revolution in particular, these things started to work really well in the real world. And then we discovered that actually people like myself who focused on machine learning algorithms, we needed a lot of help from other people. And so the field today really is, I think, critically dependent on many other disciplines. And so it's reflected in my lab and in many labs around the world. We don't just hire people who are experts on machine learning. We hire people who are experts in ethics and in design and in engineering and in all the things that you have to think about when you deploy this in the real world. And it's not just those kinds of expertise as well. It's also the domain experts. So virtually everything we do is done in partnership, whether it's in partnership with physicists who understand optics if we're doing machine learning for, let's say, cloud infrastructure, or it might be partnering in the healthcare domain with clinical experts and seeking input from patients as well, really getting that very rounded picture. So I think that really is the key to this field going forward, is having a focus not just on the algorithms, but on that multidisciplinary team approach to tackling real world problems so that we can address the ethical and societal issues as well as the algorithmic and technical ones. That's a great question.
Yeah, and just as a quick follow-up to that, some people are asking in the live chat whether it makes sense to have laws and policies that prevent you from publishing these kinds of AI models that might, let's say, have bias issues or other kinds of issues like that. They're observing that there are policies and laws for a lot of other things, but not much really in the realm of software and machine learning models. Do you have any thoughts on that?
I think there's definitely a role for regulation. Obviously, self-regulation is a very good place to start. And I think the community generally, we don't get everything right. We won't get everything right. But I think generally, I would say we're doing a reasonably good job of trying to be on the front foot of this. There are a lot of initiatives around ethics and thinking about deploying technologies in society, differentiating between whether we can do something versus whether we should do something. I think tech companies are being pretty proactive in this respect, and of course universities are being very thoughtful about this as well, and really trying to understand about the circumstances under which we should use this technology. And I think there's a real self-interest as well. I mean, I feel passionately about this not only because I care about the impact we have on society, but I believe deeply in the power and the capability of machine learning in the decades ahead. And so it's important that it does land well in society. And if we have serious missteps and we make serious mistakes in the way it's deployed, it could even backfire on the field, and we could miss out on some of the opportunities to get some of the real benefits from this technology. So I think we're all being very thoughtful about how this gets deployed. But there is a role for regulation as well. I think Yoshua wanted to chip in as well.
Yeah.
So.
I agree with what you're saying, Chris. I would add a few things. So there's a really interesting development that happened recently in the machine learning community, and that is machine learning conference organizers asking researchers to put at the end of their paper a social impact statement. And that is forcing people to even think about the question. I think that is the first step. And of course, reviewers can look at that if they think that there might be an issue in terms of what should be published and what shouldn't. I don't think that we can make regulations at this point that would draw a clear line into what should be published and what should not be published. As far as I'm concerned, right now what we're doing is very close to math, and I don't think we should prevent any kind of math to be published. However, I do think that the role of regulation in society to steer the power of technology in the right direction is crucial. Regulations, fiscal policy, these are tools that governments need to use in order to make sure that we use AI for good and we prevent the misuse or the simple, blind use. A lot of the problems we have is just lack of awareness, lack of transparency,
to just even know what the impact would be.
No, I think that's a great point, actually, and just to add that the algorithmic level, that's not something we should be legislating for. The maths or the science behind this, that doesn't make sense. Developments in computer vision could have tremendous impact in healthcare. They could be misused for surveillance in inappropriate circumstances. So it's not really the technology; it's about the way we use the technology. And certainly, I think it would actually be very difficult to try to bottle up some of these ideas. It's really a community effort. It's not that there's a single brilliant idea that's completely transformational. It tends to be much more of an organic self-organization by a large community of people interacting through conferences and publications and so on that advances the field. And that's not something that we want to slow down, but we do want to be very thoughtful about the way that gets used societally. Yeah.
Great. And I think that also addresses some of the questions people were asking about, the risks that we have in using AI in society and how we might mitigate them. And it sounds like it's a combination of, self-regulation and maybe and the community getting together. But I really do like this statement of impact that NeurIPS papers and submissions have kind of asked us to think about, because it makes us be a lot more thoughtful about the work we're putting out there before we put it out there. There's a lot of questions about again, the role between AI and people, more specifically the human consciousness. And I thought maybe, Yoshua, you might want to comment on some of these. People are asking questions about where you see the intersection of neuroscience and AI going forward, or in the discovery of the human consciousness, whether AI can really bring us towards that, towards that vision, that goal.
Right, thanks. It's a question that I care a lot about. First of all, we have to recognize that we know very little, so we need humility here. Consciousness is one of the big mysteries that humans are trying to figure out, and of course I have my own opinions, but what I see is that there's been really amazing progress in neuroscience and cognitive science to pinpoint what is going on in your brain when you're conscious of particular things and not conscious of other things. And that is helping a lot. It's essentially because we can measure things more easily. We have fMRI. We can associate that with the verbal reporting by people, and that is giving us clues that can be really useful in designing the next generation of AI systems. And why would we care? So what is very clear from studying, when is our conscious processing happening and why, is that it seems to give humans an ability to be much more robust to changes in the world, that things that happen that are very different from what you've seen in your lifetime. So if you go to a new city, new traffic laws, you have to think about the new regulations in that city, but you're able to survive. You're able to do the right things by thinking through those things. This is not habitual kind of behavior like if you're at home. And this ability to recombine old pieces of knowledge in new ways is something that current AI doesn't do very well. This is what we call out-of-distribution generalization. So humans are very good at it. Machines are not good at it. It looks like humans need conscious functionalities to get that advantage. So clearly, understanding better how the brains do it can serve as a huge inspiration. And of course, this would be useful for AI, but it would also feed back into theories that can be tested about the brain, so we can understand better how our brain is doing it. Because a lot of what is happening in neuroscience, unfortunately, is lacking enough theories. And so I think AI can play a role to help feed potential hypotheses to explain our intelligence and our consciousness.
Great, thank you for that. And your comments about the comments you just made remind me about what you said about observing how children kind of interact with the world and just being amazed by what they're able to do. And so this is just such a fascinating topic for me to think about how much we can learn from even the smallest individual in the room. So when I think about the interaction between AI and humans and our human brains, I also think about how AI has been helping us. And one of the domains that we talked about during our conversation is the healthcare domain. And so there are a couple of questions along those lines. see if I can be heard. Yes, there are a couple of questions along those lines that I wanted to maybe ask Chris. So one of the questions was whether you can elaborate on ways that in which AI can help in personalized mental health intervention. I think the questions are more along the lines of, would it just be a tool that would connect the doctor with the patient, or perhaps something more? And what kind of role you see AI playing in that interaction between the patient and the doctor, which is something I know you've thought quite a bit about.
Yeah, one thing which strikes me is that mental health is incredibly important, and it's become even more important during the pandemic. In some cases, we've seen a doubling of referrals to people suffering mental health because of all the stresses that the pandemic has brought. And yet it seems a fairly underexplored area as far as machine learning is concerned. A lot of people do, computer vision for medical imaging and so on, but mental health is relatively unexplored. So I'm pleased that we've been ramping up over the last year or two a significant research effort in this, and in partnership with SilverCloud, as I mentioned earlier, which is the leading provider in digital support for mental health, and in particular for so-called cognitive behavioral therapy. Now, first of all, I should state very clearly that our goal is not to produce some kind of AI bot that's going to deliver this kind of therapy. We're not even exploring that right now. Right. What we are looking at is ways to amplify the capabilities of the existing platform. So the platform, you can think about it in part as a way of connecting patients suffering from mild and moderate levels of anxiety and depression, and connecting them with professional therapists who can deliver cognitive behavioral therapy, which is known clinically to be very effective. And so some of the things that we're exploring early on are to do with that process of effectively allocating what is a very precious and scarce resource, namely the time of the therapists. And so how can we best utilize their time? How can we connect the right therapist with the right patients? How can we deliver the therapy at the right time? Because they have a large digital platform, they have data at scale. And I just have a very deeply held belief that if we look at the data and take a data-driven approach, we'll almost certainly be able to provide an uplift in the quality of the therapy that we're able to provide. Now, it's slightly early days, a little too early to say how big an uplift will be, but we feel that there should be hopefully some low-hanging fruit there. There's a lot of data and opportunities to take what's done already, not do something radically new, take what's done already and just optimize it in a more data-driven way. And there's a good chance that that'll make the world a better place. So we're excited to be trying to make some contributions in the mental health space as well as in healthcare more broadly.
Yeah, I'm really excited about that space as well. And I noticed, and there's a very interesting question here that comes up when you think about using AI as tools to assist doctors or clinicians and medical professionals, and that's about the error rates. So someone asked this interesting question where they said, there's an expected human error rate we have when we're working in healthcare, but how accurate do you think the AI will have to be before its decisions are trusted over a human decision? Or do you think, in another way of asking this is, do you think that the error rates that can be tolerated for AI models will be a little bit of a different, calibrated in a different way compared to the error rates that we're expected to make as humans?
That's a really interesting question. I mean, the question often comes up in terms of, let's say, autonomous vehicles, where people complain that we're demanding much lower error rates from the machine than we tolerate from humans. Let me answer the question, though, in a healthcare context, and I'll give you a specific example, which is the Inner Eye project that I mentioned earlier. So this is around using machine learning, convolutional neural nets in particular, to segment tumors prior to radiation therapy treatment. Now, first of all, there's no such thing as the correct answer. What we have is ground truth, which is segmentations that are provided by expert clinicians. Now, there's variability amongst the clinicians, so we have a fairly simple test here. We obviously use those segmentations as the training data, but we then use holdout data from different institutions. That's very important to be able to generalize to new hospitals, and we have other clinicians then segment those images, and we use that as ground truth as a measure of the performance of the machine learning system. And we look at the variability amongst clinicians. So I have several clinicians segment the same images, and when our system has a prediction that's within that range of variability of humans, when it's essentially performing at the same level as humans, when its error is within that band, then we believe we have something which may be clinically useful. But we do something else as well, which is in this application, what happens is normally the standard workflow today is that the clinician will do the segmentation manually, meaning they'll look at a screen, they'll have a stylus, they'll go through the 3D image layer by layer and segment by hand. That can take 20 minutes easily. It can take many hours if the tumor's metastasized. There are many regions to identify and segment. That can take many hours. Our system can produce a segmentation obviously extremely quickly because it's a trained neural network. But then the clinician will go through that candidate segmentation and will then have an opportunity to modify it. So instead of doing everything from scratch, they're starting with a candidate segmentation, and they can then go through and modify. So even if the neural net is producing errors, the clinician can still look at them and say, do you know, actually, I'd like to include, I'm not quite sure about this region, I think I'll include that in the therapy, or this looks like healthy tissue, perhaps I'll just back off a little bit and exclude that from the segmentation. And so finally, it's the clinician is still responsible for producing that segmentation. And so it's a very nice example, I think, of partnership between the human and the AI. The net result is that the overall workflow is sped up enormously, and literally from 20 minutes to several hours, all the way down to just a couple of minutes, including that process of verification and making fine tweaks. So that's in a way, that's how we answer that question of is the error good enough? Really by saying, if it's producing essentially a segmentation the clinician is happy with, and it's doing it in a fraction of their time, then it's very successful in terms of empowering the clinician. We're not claiming the neural network is perfect, but it's producing a candidate segmentation that's sufficiently good that very little fine-tuning, if any, is actually needed by the clinician.
Got it. Okay. I think that makes a lot of sense. It's this kind of collaboration and this collaborative effort and kind of judging the accuracy based on this combined effort. And I really like that. I do agree that in general, this question of how accurate ML models have to be and what standards they're held to is a very complicated one and really depends on the domain you're looking at. And we have a lot to figure out here. Speaking of this kind of the healthcare situation, I can't ignore the current environment that we're in right now. And I was wondering if Yoshua, you wanted to comment on a question that some of the audience members had about examples in which AI and ML has helped us in coping with or understanding the COVID-19 situation.
Right. ML is being used in many ways to deal with COVID-19, but I don't think that there is a super breakthrough. I mean, otherwise, I guess we would know. There's been a lot of effort initially in medical imaging, so for diagnostic. There has been effort at Mila, for example, in the logistics of healthcare. So as Chris was talking earlier, one of the uses of machine learning is in better allocating resources based on better predictions. So like, how many nurses are we going to need in this particular area because of the growth of demand in treatment for COVID-19 or other medical problems, because somehow you have to allocate also taking into account these different issues. So that's another example. In my own group, we've been working on two projects that involve trying to help with COVID-19. One was in the development of AI-driven contact tracing that would be more accurate than the standard that is currently deployed around the world, by taking into account information that people can report on their phone about their symptoms, for example, and their comorbidities or other conditions they may have. And then the other project that we're working on and is going to start hopefully in January, biological assays, is the development of new antiviral treatments using combinations of existing drugs. We also have another project where we're designing de novo drugs. So there will be people for whom vaccines may not work well, and we need to have better treatments for them. So this is an important area. Within the next year, as we're deploying the vaccines, we're going to discover that there are still people that fall through the cracks and will need those treatments.
Great. And Chris, you wanted to say something about this as well?
Oh, I was just going to give an example actually of a pre-existing project that was actually able to pivot very rapidly. I mean, one of the things we saw with the pandemic was the very agile way in which many teams around the world in many institutions were able to pivot. And there's a rather nice example that involves a company in Seattle called Adaptive Biotechnologies, where we have a partnership with set up a few years ago. And Adaptive has this particular capability, which is sequencing the DNA in white blood cells that codes for the receptors on the surface of T cells. So these are the sort of randomized little receptors that match antigens and detect that either there's been a foreign invader or perhaps there's been a mutation, a cancer, but there's something that's unexpected in the body and it can mount a response. And we've been looking at things like Lyme's disease and various other things, combining their sequencing capability together with Microsoft's machine learning capability and compute resource. And I'll actually be talking a little bit more about this in the Posner lecture, so I won't sort of give away too many of the details here. But one of the interesting things that has emerged from this is the realization that the body's T-cell response, because the body has this amazing adaptive immune system that recognizes that there's a new invader, and not only is able, hopefully, to defeat it, but also to remember in the future that it's seen that invader and can deal with it. And so, in the case of COVID-19, there are these two responses: the antibody response and the T-cell response. And early indications are that antibodies from COVID-19 can decay relatively rapidly. And what this study has found is that the T-cell response seems to persist for much longer. So there'll be more to share about how this is actually going to be used to create a new test to detect whether somebody has had COVID-19 in the past through looking at T-cell responses rather than antibody responses. So that's quite an exciting example, I think.
Very cool.
I'd like to mention a couple more examples, actually. So two on the natural language processing front. There's a Canadian company called Blue Dot that in fact, by analyzing what was going on the internet in terms of messaging, very early on in 2020, detected that the pandemic was starting. So we can use the information exchanged by humans and process it to give us warning signals. So that's one example that happened at the beginning of last year. The other example, more recent, is work to try to cope with the infodemics. There's a lot of false information that is circulated about COVID-19, about the effectiveness of treatment and so on. And false information can be very dangerous. And so there's work in analyzing, again, social networks, even speech from radios. And in poor countries, they use a lot radio to propagate information, to find out about where are these false information is being disseminated so they can be quickly corrected. And then the last thing I want to mention is protein folding. So one of the problems is we don't know the 3D structure of many proteins that are the targets for vaccines or antivirals. And one of the early uses of these techniques, which are very interesting because there's been recent progress recently, has been to provide very early on, before the proteins were actually crystallized, which takes a lot of time, to provide some early 3D scaffold that can help medical research design new treatments for the disease.
That's fascinating. Cool. I've not heard about that. That's great. So these are, I think, all very interesting examples of how AI and ML can help us understand the problem and address it. And I think it's super valuable that both of you are thinking about it and spending time on it, especially as we emerge out of this process, hopefully very soon. So one question that came up in the chat a lot was, I guess, a more general question, but related to this idea of how AI and how people kind of view AI contributions and AI tools that we use. So someone asked what we see as the biggest public or industry misconception about the capabilities of AI systems and where they're useful. I find this question interesting in the light of what you just said, Yoshua, because you just mentioned an example where AI can help you maybe even understand and filter out inaccurate information or fake information about a particular topic. And this question is kind of a flip side, saying, are there ways in which we misinterpret what AI can do as a society? And what you think might be the biggest way that the public misconstrues what AI is capable of?
Was that for me or for Chris?
Oh, either one. Chris, do you want to take it on, Chris? Yes.
Well, I can have a stab, and maybe
Yeah.
Yoshua can do better. But I guess one of the things is that it's misconstrued in probably every conceivable way. I think one of the challenges with AI is that it means so many different things to so many different people. It's almost ceased to have value as a way of communicating a concept because it's so widely used. And so people sometimes use more specific terms. They'll talk about artificial general intelligence, meaning a sort of very ambitious aspiration to produce human-level intelligence in machines, or they'll talk about machine learning to focus particularly on the technology. So I think part of the problem is it means so many things to many people that there are probably many misconceptions out there, and I tend to try to use more specific language. I do think for me there are two very real things that are very exciting. One of them is this aspiration to really get to the heart of the nature of intelligence, and to see how we can really push the frontiers of what machines are capable of in terms of intelligence. And I see that as much as anything as a scientific endeavor. It's very inspiring. It's the thing that really caused me many decades ago to switch from theoretical physics into the field of machine learning. I do think, though, that's a long-term scientific aspiration. There's also something very concrete and near-term, which has very little, I think, to do with that aspiration. It's quite distinct. It's to do with the comments I made earlier about really a revolution in the way we create technology, that we're seeing this. I think it is a revolution, a very fundamental transformation in the paradigm for creating software, and therefore for creating technology, because most technology today uses software, which is that shift from handcrafted software to software that's learned from data. And that's quite transformational. It's quite pervasive, and it's happening right now. And I think it's very exciting. And I think perhaps one of the, if not misconceptions, but perhaps lack of full appreciation sometimes that I see, is appreciating just how deep and how pervasive that transformation is going to be.
Great.
Joshua.
Yeah, so I wanted to add a couple of things. For me, the worst misconception that is hurting us all is the view that maybe comes from science fiction, or maybe people's wishes that AI is sort of magic. And it's actually people thinking about current AI is magic, but connecting to what Chris was talking about regarding AGI, I think there, even within the machine learning community, people who think about future AI as something magic, which I don't think makes any sense. There's another aspect I want to mention to this that has to do with society. So as AI is being deployed more and more in the world, we have to take collective decisions, governments, communities, about the modalities that we want for this to happen. We've talked about regulation, but it's deeper than that. It could be local, it could be national, it could be international. But for this to happen, it's going to require not just the politicians to become aware of these issues, but also regular citizens. They need to understand that there may be, say, a military danger if we don't act with an international treaty about lethal autonomous weapons. If they don't understand the danger, if they don't understand the potential benefits, then I don't think that our governments are going to do what it takes. It's not going to be a priority. And so education of the general public, so that they understand the basics of AI science as it is today, and how technology can be used for good and for bad, is crucial.
So I think that's very interesting that you raised that point. There are a lot of questions in the chat, as you might expect, about whether we're close to achieving artificial intelligence or what the future of it is, and a lot of these questions I think are shrouded in this perspective that there is something magical about AI. Do you have a recommendation for how people might educate themselves to get better calibrated as to what AI can really deliver in its current stage?
Read.
Read. Okay.
There's so much being written about AI. Mm-hmm. Not all of it is good, but in general, if you read from trust people, scientists, this is a good source. And engage in a discussion. So as I was saying, I believe that at some point, the sort of dialogue we're having today should be one that involves society in a broader sense, especially disadvantaged, vulnerable communities. So there's going to be a democratic debate about technology. What is it we want? What is it we don't want? So read, get involved. Don't believe everything you read, because you will also see all kinds of crazy claims. And my last comment is I don't like the term AGI. I don't think there is even such a thing. Like, our intelligence is not completely general. We have evolved with some skills. So our intelligence is specialized. We can't solve every problem, as we know, right? And so we're not completely general. And even like learning theory tells us there is no general intelligence. There's always going to be some inductive bias, meaning that there are things that a learning system can do well and others that it can't by construction.
Yes, I think that's an important thing to remember. Oh, go ahead, Chris.
Yeah, no, I like that perspective a lot. I think there are many axes of intelligence, and if you think about, I mean, just adding up a column of numbers is a kind of intelligence. It's a form of information processing, and machines have long been way ahead of most of us in that ability. And what we're seeing is challenges such as, just understanding visual scenes, recognizing objects, or translating languages, and so on, where the state of the art was way behind human capabilities some years ago, and where it's now much more comparable to human capabilities. And yet there are plenty of other areas where machines fall far behind humans, and so intelligence doesn't appear to be this one thing that magically one day we'll solve it and there it's there in all its glory and it's done, but rather these many different facets, and we see progress on different fronts. And we've seen a burst of progress in the last few years. The next few years look to be very exciting, but then are these sort of very deep, open questions where we're perhaps not really too sure how we're going to make progress. What I will say all up, though, is what an amazing time to be in the field. I think this is just an incredibly exciting time to be in the field. We've got this tremendous mix of sort of real-world practical applications tackling really important problems like climate change and healthcare, and at the same time some very fundamental questions of a very scientific nature that are tremendously inspirational, and which themselves, if we can make some progress, could in turn have bring further societal benefits. So I think fantastic time to be going into the field.
Yeah, I think those are great examples. Actually, I've been doing some work in chess where we look at how humans play and how chess engines play, and look at their strengths and weaknesses. And when we're talking about where humans and how they compare, we realize this example that you gave, which is that computers have been much better at us at adding up numbers for a long time. There are simple examples where the AI has strengths that we don't have, and vice versa. So I think it's an interesting comparison that you can't just make a blanket statement about. I agree it's an exciting time to be in for AI, and a lot of the questions in the chat were from people who are trying to enter this field because they're so excited about the things that you and Yoshua have talked about and the developments that they're seeing, and a lot of them are asking for advice. And so I thought it'd be nice to end this Q&A with some advice you might have for undergraduates or even business practitioners who are trying to incorporate AI or learn more about AI. So entering into the field of AI as an undergraduate, do you have any advice for students, Chris, on how to go about doing that?
Yeah, I have. I'm tempted to recommend a good book or two at this point, but I think the thing that I would recommend most of all, particularly for students who are wanting to study this field in depth, maybe even go on and do a PhD or really work in industry, really focus on this for a career, is that it's actually very helpful to get some good maths under your belt. So if you really want to understand machine learning, you do need, you don't need to be a mathematician, but there's a few core ideas in maths that really help. And in particular, some basic calculus, particularly multivariate calculus, just really understanding the basic ideas of calculus. Basic probability theory, you don't need a ton of sort of measure theory or anything like that, but just really being able to manipulate probabilities and conditionals and marginals and so on.
And understand what you're doing when you do that.
And understand what it means and avoid paradoxes and all the rest of it. Yeah, so the math there is very simple, but conceptually it can get quite complex. And linear algebra, of course, just getting pretty proficient at just sort of matrices and vectors and so on. That maths
and optimization.
Optimization, gradient optimization methods and so on, and then thinking about some of the stuff that layers on top of that around causality and all the rest. But actually just some basic skills at maths, or going and taking some maths courses. Some people get put off, it's hard, but it's a skill that's really worth acquiring. And so I think my one piece of advice is when you're faced with a sort of a choice of which courses to take, try to increase your skills in maths, particularly probability, linear algebra, multivariate calculus. You won't go wrong.
Makes sense. And then Yoshua, is there any advice that you might give yourself, or in hindsight that you wish you had when you decided to enter into this field?
Yeah, sure. I'd add a few things to what Chris said. So math, of course, but you also need to be good in computer science, because we are doing these complicated experiments, sophisticated code, libraries, and so on. So there's a lot of software engineering. You need to understand the basics of computer science and have the right courses there. The last advice, and this could have applied to me when I was younger, as an undergrad, what we're looking for today a lot, when I get hundreds of CVs every year undergrads who want to do work in machine learning. And I would say, get your hands dirty. Work on projects. Work on at least one project per year. It could be within courses. It could be something you do on your own. There are a lot of open source projects that you can contribute to. There are a lot of papers you can read and just try to reproduce the results of those papers. If their scale is small enough that you don't need supercomputers. So that's going to make a difference both in terms of your intuitive understanding of the field, because you get your hands dirty, you do things yourself, but also it's going to help on your CV to reassure, say, a professor that you might have the right skills to get quickly off the ground in a project.
I completely agree with that. I think that when you get your hands dirty and you talk about what you did, it comes out and it shows when you write about it. And then people who are looking at your applications, they can tell, oh, this person's really gotten into the meat of that problem. So I think that's great advice. I want to thank our guests again. Thank you so much, Yoshua, and thank you, Chris, for taking time with us to talk about the opportunities that AI and machine learning can bring to so many different fields and domains in our world. And it's just an especially timely time to talk about these issues. So thank you again for the live Q&A. And thank you to the audience for attending the talk and for submitting all your questions. I'm sorry we couldn't get to all of them, but hopefully we covered a range of them. And hopefully you can enjoy the talk later on as well if you have further questions. Thank you so much.
Thanks to you.
Thanks, Sid. Thank you.